Hello and welcome to this short presentation on performing mole calculations when one of the reactants that you've been told about is a solution. So you do need to know a few things before you carry on with this. You should know how to balance simple equation, and by this point this should really be down. And you should also be comfortable working out the number of moles in a solution. If you're not, I have a previous video, please go and watch that. Okay, so concentration. You may be given the concentration of a solution in two different ways. The first way is in grams per cubic decimeter, and the second way is in moles per cubic decimeter. Now, what you need to pay note about is the way that the units are given here. Okay, so the units here will help you decide which one you've been given. And the reason that we use solutions in chemistry is actually sometimes it's more tricky to use the neat compound than you realize. It might be because of safety reasons. It might be because it's going to be easier to use the solution, or actually it might just be easier to store it. So there's three reasons there why we might use a solution rather than the neat compound. Okay, so working through an example with grams per cubic decimeter, if I give you this simple equation and then this question, so how much copper oxide will react with 25 cubic centimeters of a 73 grams per cubic decimeter solution of HCl? Well, we've been given the volume of HCl that we've reacted, and we've been given the concentration, but we haven't been given the mass. So that's going to be the first thing that we need to work out. And we use this equation. So if the concentration in grams per decimeter cubed is the mass divided by the volume, then we need to rearrange that equation so that mass is equal to the concentration times the volume. We know these two things, but we do need to remember that we need to use the units of decimeters cubed, and 1 decimeter cubed is 1,000 centimeters cubed. Okay, and I've taken that into account here. So we've been given the concentration of 73 grams per decimeter cubed. We've got the volume, and in decimeters cubed that is 25 divided by 1,000 in this instance. So I've actually used 1.825 grams of HCl. And that's not the end of this question, okay? So if I've used 1.825 grams of HCl, I can now work out the number of moles of HCl used, because moles is the mass divided by the MR. In this case, it's 1.825 divided by 36.5. And that equals 0.05 moles of HCl used in the reaction. We can now use that to work out the number of moles of copper oxide. Now, the mass of copper oxide used is going to be the moles times by the MR, but notice we are in a 1:2 ratio of copper oxide to HCl. So therefore, whatever number of moles of HCl I have half the number of moles of copper oxide, which I've taken into account here. So it's then 0.05 divided by 2 times by the MR of copper oxide, which is 79.5, and it comes out as 1.99 grams. Okay, I hope you followed that. We're going to do another example now in moles per decimeter cubed. Okay, so a similar reaction, except instead of HCl, I'm using a sulfuric acid. So how much copper oxide will react with 25 cubic centimeters of a 2 mole per decimeter cubed solution of H2SO4? Now, sometimes actually you might be given a 2m, 2 molar, and 2 molar is the same as 2 moles per decimeter cubed. Okay, now we don't need to do the first step that we did before because we've already been given the number of moles essentially, but the moles of H2SO4 used is equal to the concentration in moles per decimeter cubed times by the volume in decimeters cubed, which we do have to change, okay, because we've been given it in centimeters cubed. So we need to have our 25 divided by 1,000 there. So the concentration is 2, times that by that 25 over 1,000, and I get 0.05 moles. The mass of copper oxide used, again, very similar to the previous example, is moles times by the MR, except here I've actually got a 1:1 ratio of copper oxide to sulfuric acid, and therefore I don't need any multipliers when I'm talking about the moles. So it becomes 0.05 times by 79.5, and that equals 3.98 grams of copper oxide reacting with 25 cubic centimeters of a 2 molar solution of H2SO4. I hope you enjoyed this presentation and have fun working out lots and lots of mole calculations using solutions. Thank you very much. Bye bye.